Hey guys, this is our last example in lesson 9.5 for a geometric series. And this is example 3a. In example 1, we did the sum of a finite geometric series. There's a start, there's a stop. In example 2, we talked about whether a series that's infinite could find a sum or couldn't. So a series where the absolute value of the ratio was less than 1, which meant each consecutive number got smaller, those I could find a sum for. And this is the formula for an infinite series. I'm going to put the infinite sign right there, which means there is no stopping in this series. I need my first term, but I no longer have an n value. There's no stop. So it's just the first term divided by 1 minus the ratio. Okay, so let's just do a couple examples here for this one. Letter A, we'll go 1 plus 1/2 plus 1/4. We did this in the last video for converging and diverging series. I already know my sum should come out to be 2. Let's plug it into our formula and find out. First term, a sub 1 is 1. My ratio, what do I multiply to get from one number to the next? You would take the second term, if you can't tell right away, because they're not always going to be this obvious, take the second divided by the first, and that will give you what your ratio is. So 1/2 divided by 1 is 1/2. Okay, so 1 divided by 1 minus r. 1 minus 1/2 is still 1/2. And I'm sure you remember fondly from when we divided rational expressions that when you divide your fraction, you keep the first, change division to multiplication, and flip the second. So keep, change, flip. Okay, let's just do one more example. Actually, let's do 2 more examples. Okay, letter B. I have 1/3 minus 1/9 plus 1/27 minus 1/81 plus dot dot dot. Okay, dot 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 means infinite series. The formula for infinite series, all I need is the first term divided by 1 minus the ratio. First term is 1/3. My ratio, if you don't know right away, take the second divided by the first. That's an A, not a 9. So the second term is negative. That negative sign belongs to the 1/9. Divided by the first. Remember, in fractions, you keep the top number, change it to multiplication, and flip the bottom. My ratio is negative 1/3. If you recognize that in the beginning, you don't have to go through the process of figuring it out, but negative 1/3. Let's keep the negative sign. There's no powers involved, so right away I can take care of that double negative. 1/3 divided by 1 plus 1/3 is 1 1/3, or 4/3. So keep, change it to multiplication, and flip the second fraction. Numerator, denominator cancel. The sum of this infinite series is 1/4. And you are more than welcome to grab your calculator and test it out. Start adding and subtracting the series and see if you're getting closer and closer to 1/4. Okay. One more example to go. So again, the answer to this one was 1/4. Example 3C, I just want to do one that's in summation notation. So you guys can see what that looks like. Where n equals 1, and this time they're going to give you the infinity sign at the top. Okay, 2/3 to the n power. My formula for sum of an infinite series, first term divided by 1 minus the ratio. To get my first term, and we've done this a couple times now, this number tells you what n is going to be on your first term. So I have 2/3 to the first power. And it's only 1 because they tell me to start at 1. If there's another number here instead of 1, you've got to use that as your power. And the ratio is this number inside the parentheses that's being raised to the power. So the sum of an infinite series, where my first term is 2/3, and 1 minus my ratio of 2/3. You can type all that in the calculator, but let's do it by hand. I'll take 2/3 divided by 1 minus 2/3 is 1/3. Keep, change, flip. Numerator to denominator cancels, leaving me with 2. Okay. And that is lesson 9.5.